Today we're going to build a complete understanding of linear equations and inequalities. This topic shows up everywhere in algebra. It shows up when you solve for an unknown, it shows up when you graph a line, it shows up when you model real-world situations, and it shows up when you describe limits, like at most, at least, less than, or greater than. At first, linear equations and inequalities can feel like a bunch of separate rules, but all these ideas are connected by one simple theme: balance and change. Equations are about balance, graphs are about change, and inequalities are about limits. By the end of this video, you should understand how to solve linear equations, how to graph linear relationships, how inequalities work, and how to turn word problems into math. So let's start with the most important question. What does it actually mean for something to be linear? A relationship is linear when it changes at a constant rate. That means every time x changes by the same amount, y changes by the same amount. On a graph, this creates a straight line. The most common form of a linear equation is y equals mx plus b. This is called the slope-intercept form. The letter m represents the slope. The slope tells us how quickly the line changes. More specifically, the slope compares the change in y to the change in x. You can think of slope as vertical change divided by horizontal change. So when the line moves to the right, the slope tells us how much it moves up or down. The letter b represents the y-intercept. The y-intercept is where the line crosses the y-axis. That happens when x equals 0. So in the equation y equals mx plus b, the b value tells us where the line starts on the y-axis. Then the m value tells us how the line moves from there. This is why slope-intercept form is so powerful. It gives us two pieces of information immediately: where the line starts and how the line changes. So linear does not just mean a line, it means constant change. Every step in x produces a predictable step in y. That is the big idea. Linear means constant change, and the graph is a straight line. Now let's talk about solving linear equations. Solving an equation means finding the value of the variable that makes the equation true. The best way to understand this is with a balance model. An equation has two sides, the left side and the right side. The equal sign means that both sides have the same value. So if we change one side, we have to change the other one in the same way. That keeps the equation balanced. So let's solve this equation. 3x plus 5 equals 17. Our goal is to get x by itself. Right now, x is being multiplied by 3 and then 5 is being added. To isolate x, we undo those operations in reverse order. First, we undo plus 5. The opposite of adding 5 is subtracting 5. So we subtract 5 from both sides. On the left side, plus 5 and minus 5 cancel. That leaves us with 3x. On the right side, 17 minus 5 is 12. Now the equation is 3x equals 12. We are closer, but x is still being multiplied by 3. To undo multiplication by 3, we divide both sides by 3. On the left, 3x divided by 3 leaves x, and on the right, 12 divided by 3 is 4. So x equals 4. Now we check. If x equals 4, then 3 times 4 plus 5 equals 12 plus 5, which equals 17. That matches the original equation. So the solution is x equals 4. The key idea is this. Solving equations means keeping both sides balanced while undoing operations step by step. Whatever you do to one side, you have to do to the other side. Now let's graph a linear equation. Suppose we want to graph y equals 2x minus 3. This equation already is in slope-intercept form, y equals mx plus b. That means we can identify the slope and the y-intercept right away. The b value is negative 3, so the line crosses the y-axis at negative 3. That gives us our first point, 0, negative 3. Now we look at the slope. The slope is 2, but when graphing, it helps to write 2 as a fraction. 2 is the same thing as 2 over 1. That means rise 2 and run 1. Starting at the y-intercept, we move up 2 and write 1. That gives us the second point. Now we have 2 points. And 2 points is enough to draw a unique straight line. So we draw the line through these 2 points. And that is the graph of y equals 2x plus 3. The y-intercept tells us where to start, the slope tells us how to move. And this is the most important idea when graphing lines in slope-intercept form. B is the starting point, M is the movement. And because the change is constant, the points will always fall on this straight line. So whenever you see y equals mx plus b, think of it as a set of graphing instructions. Start at b and then use m to move. Now let's move on from equations to inequalities. An equation tells us two expressions are exactly equal. An inequality tells us one expression is greater than, less than, greater than or equal to, or less than or equal to another expression. This usually means there is not just one solution. There's a whole set of possible solutions. Let's solve this inequality. 2x minus 4 is less than or equal to 10. We solve this almost like an equation. First, we want to isolate x. So we undo minus 4 by adding 4 to both sides. On the left side, minus 4 and plus 4 cancel. That leaves x. On the right side, 10 plus 4 is 14. Now we have 2x is less than or equal to 14. Next, we divide both sides by 2. That gives us x is less than or equal to 7. So the solution is every number less than 7 plus 7 itself. On a number line, we can put a filled circle at 7. The filled circle means 7 is included, and then we shade to the left because x can be less than 7. That is the main difference between solving an equation and solving an inequality. An equation gives a specific value. An inequality gives a range of values. Now, there's one rule students forget all the time. When you multiply or divide both sides of an inequality by a negative number, you must flip the inequality sign. For example, let's solve negative 2x is less than 6. To isolate x, we divide both sides by negative 2. Because we divided by a negative number, the less than sign flips into a greater than sign. So the answer is x is greater than negative 3. On a number line, negative 3 is not included because this is a strict inequality. There is no equal sign. So we use an open circle at negative 3. Then we shade to the right because 3 is greater than negative 3. So remember this rule carefully. So adding or subtracting does not flip the inequality sign. Multiplying or dividing by a negative does flip the inequality sign. That is one of the most important rules of solving inequalities. Chapter 5. Now let's apply linear equations to real situations. Here's the first example. A taxi charges $3 to start and then $2 per mile. How much does a 6-mile ride cost? The first step is to identify the starting value. The taxi costs $3 before any miles are driven. The starting value is 3. Next, we identify the rate of change. The cost increases by $2 for every mile you drive, so the rate of change is $2 per mile. Now we can write a linear model. C equals 3 plus 2m. C represents the total cost, m represents the number of miles, and the 3 is the starting cost. The 2m is the cost that depends on the number of miles. Now, the equation asks for a 6-mile ride, so we substitute m equals 6. C equals 3 plus 2 times 6. 2 times 6 is 12, and 3 plus 12 is 15, so the total cost is $15. On the graph, the starting cost is the y-intercept. That is a point where the ride starts and the number of miles is 0. The slope is 2. Because the cost increases by $2 for every 1 mile, the slope is 2, because the cost increases by $2 for every 1 mile. This is a linear relationship, because the cost changes at a constant rate. Every extra mile adds the same amount. Now, let's look at an application with an inequality. You have $47. Each notebook costs $5, and you already spent $12. How many notebooks can you buy? Let n represent the number of notebooks. Each notebook costs $5. So n notebooks cost $5n. You already spent $12, so the total amount spent is 5n plus 12. Since you only have $47, the total must be less than or equal to 47. So the inequality is 5n plus 12 is less than or equal to 47. Now solve it. First, subtract 12 from both sides. That gives us 5n is less than or equal to 35. Then we divide both sides by 5. That gives us n is less than or equal to 7. So you can buy at most 7 notebooks. The phrase at most is important. It means 7 is included, but you cannot go above 7. On the number line, we use a filled circle at 7 and shade to the left. In applications, the inequality symbol tells you the real-world limit. Less than or equal to means you could go up to that amount, but not beyond it. Greater than or equal to means you need at least that amount. So when solving word problems, do not just calculate. Interpret what the answer means in the situation. That is what turns algebra into a real model. Let's recap the full lesson. A linear equation describes constant change. The most common form is y equals mx plus b. In that equation, b is the starting value. On a graph, b is the y-intercept. The slope m tells us how the line changes. It compares vertical change to horizontal change. To solve a linear equation, keep both sides balanced. Whatever you do to one side, you must do to the other side. To graph a linear equation in slope-intercept form, start at the y-intercept. Then use the slope to move. For example, a slope of 2 means rise 2 and run 1. For inequalities, remember that the solution is usually a range of values. A filled circle means the boundary value is included. An open circle means the boundary value is not included. Shade in the direction of the possible solutions. And remember the most important inequality rule. If you multiply or divide by a negative number, you must flip the inequality sign. Finally, in applications, translate the words into a model. Look for the starting value, look for the constant rate of change, then decide whether the situation is an equation or an inequality. Equations describe exact values, inequalities describe limits. The big idea is this. Linear math describes constant change and clear limits. Once you understand that, solving, graphing, and applications all become part of the same story. I hope this video helped, and if it did, consider hitting the like button and subscribing to the channel.